Hello everyone, you are welcome to our channel once again. Today we shall be discussing on how to calculate the temperature of the brake of an aircraft while touching down. Once again, how to calculate the temperature of aircraft's brake while touching down. Today we are given an aircraft brake data and equation. We are given the aircraft landing weight, maximum landing weight as 250,000 kilograms. We are given the initial temperature of the brake as 15 degrees Celsius. We are given the horizontal velocity of aircraft on the touchdown Vmax, which gives us 360 km per hour. So by converting it to meter per second, we are given the outer diameter brake disc to be 0.30 meter. We're given the inner diameter brake to be 0.05 meter and the thickness of the rotor disc to be 0.02. Also, we are given the thickness of the stator disc to be 0.025 meter and the number of the rotor in the brake assembly to be 4 and the number of the stator in the brake assembly to be 3 and the number of the wheel of the craft, which is 3 wheels. Also, we're given the kinetic energy dissipated by brakes, which is supposed to be 50%, which is 0.5. Also, we're given the material properties of our disc, rotors, and stators. So the density of the asbestos, which is the rotor, is 2,800 kilograms per meter cube, and the specific heat is 1.05 kilojoule per kilogram Kelvin. Also, we are given the cast iron disc stators, its density to be 7,800 kilograms per meter cube. Also given is the specific heat of the cast iron stator to be 0.5 kilojoule per kilogram Kelvin. Now, with all these numerous input and data given, how do we calculate the landing temperature of the brake of the aircraft? Once again, how do we calculate the landing temperature of the brake of the aircraft, which is T1? First of all, by using the formula given, which is EK, that is the kinetic energy of the aircraft, which is half of the aircraft maximum landing weight multiplied by the horizontal velocity of the aircraft by touching down. So that gives us EK equals half multiplied by 2,500 multiplied by 360 times 1,000 over 3,600 squared. So that gives us 125 million, which is 125 megajoules. Also, by calculating the heat generated, that is the heat generated while the aircraft is landing down, that gives us the percentage of heat dissipated, which is given 0.5 multiply by the kinetic calculated, that gives us 625.0000 calculated, which is 62.5 megajoule. Now, in order for us to calculate the brake temperature while the aircraft is touching down, we use the below equation here, which is change in entropy equals the product of the number of the aircraft wheel brake to the following equation. So by slotting all our values into this particular equation, our T1 becomes 589.5 Celsius, which is approximately 590 Celsius. So once again, the final temperature of the brake of an aircraft while touching down with all the data given is 590 degrees Celsius calculated. Thank you very much.